We've done a lot of studies showing that when you ask what they think kids can learn, they greatly underestimate it. We did one study where we showed kids a 7-minute video that is designed to teach adult technicians how to take apart and assemble and repair a diesel engine. And we asked teachers, could we show this to a kindergarten? Would they get anything out of it? And they said, of course not, it'd be stupid. They adored it, and they learned all sorts of abstract principles. And we had to do it certain ways, we had to make it work. But you can actually engage them in surprisingly abstract things, even before they can speak.
I'm Brandon Vaidyanathan, and this is Beauty at Work, a podcast about how beauty shapes our world and the work that we do. In this season, we're looking at beauty in science. This episode is sponsored by Templeton Religion Trust and the Institute for Advanced Catholic Studies at the University of Southern California. More about them later in the show. Hey everybody, I am so thrilled to have with us my guest today, Professor Frank Keil, who is Charles and Dorothea Dilley Professor of Psychology at Yale University, where he is also a member of the Cognition and Development Lab. He's the author of Developmental Psychology, The Growth of Mind and Behavior, and other books. He has spent almost 50 years researching how people of all ages make sense of the world around them. And his latest book, which I highly, highly recommend, is Wonder, Childhood and the Lifelong Love of Science. Frank, thank you so much for joining us. It's such a pleasure. It was such a pleasure reading your book and now to have you on the podcast.
Well, thank you for having me. I love the project you've been working on, so it's really a pleasure to talk to you.
Great. Let's talk about what wonder means. How would you define it? How is it different from awe and curiosity? Those are two other words that people throw together.
Yeah, it's important to keep apart the sense that wonder's had various senses over the years, and sometimes it's varied pretty close to awe, sometimes quite different. I see it as, I propose to use it as a much more active sense of really wanting to know what lies beneath, trying to find out, asking questions like why and how, what if. Awe can sometimes be seen as sort of standing back and going, oh, wow, isn't this beautiful? And almost kind of a more dumbstruck, passive mode. So I very much want to get the notion of engagement and question asking and exploration. And curiosity can be about facts. I think wonder is more about mechanism. Why does this work? Why is it this way? So if you're just curious about what the batting average of Ted Williams was, that's not so interesting to me. I want to know why he was able to do that. How come he could see the seams on the baseball and stuff like that?
That's great. So what attracted you to this topic? Why did you set out to write this book, and what did you find along?
A bunch of things. I think I was surprised to learn just how much whatever we can think of as question asking and wonder-like behavior seemed to crash when kids hit elementary school. You know, they're going up to asking sometimes wonder every few minutes in this four-year-old, and then they hit school, and some classic studies document that sometimes they will ask one or two why questions a day or none. It's as if it gets completely stifled. Now, I don't think it's on purpose. I don't think people are trying to do this, but what happens is a convergence of negative factors. Many teachers underestimate that children can understand deep, abstract things and causal kind of arguments. So they just give them facts, but they don't want the facts. They want to know why those facts exist. The huge pressure in many countries towards standardized testing and assessments reinforces that fact-based kind of litany. The pressure on teachers with large classes to get results makes it very hard for them to have engaged discussions with kids. I talk at some length about the Finnish Revolution in schooling, which resulted in a lot more kind of wonder kind of activity. So I think it's totally doable, but I was concerned about that. And then, I noticed that there's some people who are lifelong wonderers who are just amazing. Richard Feynman is a wonderful example. And Jennifer Doudna in the genetics area. These people, if you read their biographies, we just couldn't help but want to know how the world works from the moment they were born practically, and they never stopped. The hunger was so strong. There's some wonderful cases in history. Thomas Young, this polymath back in the 18th century, who discovered everything from physics to music to life insurance. These incredible patterns. These people, when they're on their deathbed, they just want to know more. That's what they care about. Nothing else matters. And then my own self, I just joy in learning about things. And I said, why is this so fun?
Yeah. So was there anything you discovered as you were putting the book together that surprised you, that you didn't expect?
A few things. And one thing I'm actually working on more now is the sort of mechanism, encroaching desert, I call it, the way in which the world is becoming less obvious to children, how it works. My 1963 Triumph Spitfire had 0 transistors in it. It didn't have a radio. a comparable car today, like a Mazda Miata convertible, has something like 3 billion transistors. Everything's encased in blocks or silicon. You can't tell what the hell anything works. You talk to undergraduates, they have no idea. Now, they might say they know code instead, but they don't really know code. They know how to use it. So I worry that the most revealing, interesting things about how things work in the world are disappearing a bit. And I'm trying to get a better handle on that. So that surprised me. I was surprised at how wonder is so powerful in young kids. I had not realized how much it spurts before any schooling starts and how it surges. And then I was really surprised at how it gets shut down.
Right. Well, I'd love to follow up on a couple of those things as we go through along. I mean, so let's talk about I guess one of the core things that you argue here is that what we're wondering about fundamentally is causal mechanisms, right? That really is what children, as well as scientists, the scientists we talk to, we find that just across the countries that we studied, it was some 70+% of scientists, for them, what they find beautiful about science is the ability to grasp the inner logic of systems or the hidden order behind the patterns they see. And that seems to be, from your work, it suggested that this is just a natural extension of what we're drawn to as children. What are causal mechanisms, I suppose, and what draws us to them as children?
Well, we were surprised, because we've done some work in our own lab, on just how driven kids are to understand mechanisms. If you do a magic trick to a young kid, they want to crawl behind and take apart the device and figure out how the hell you did that. They like mechanisms more than facts. We've done a lot of studies showing this. They just really want to know why and how. The reason why they do that, it gets a much better payoff. It gives them more inductive power. If you know something about mechanism, you're more likely to figure out what else has the same mechanism. So it's a much more powerful insight. They prefer experts who know mechanisms over experts who know facts. This is before they go to school. So they've learned this is a very powerful tool towards figuring out what the world is like. I don't know if they like all mechanisms. I think they like the ones that are like clockworks, the ones that look kind of, they can almost visualize. And I think that maybe because we're sitting on top of a spatial system that's very evolutionarily old. So I like to see things laid out kind of spatially. Interesting question about this when we get into sciences is some people in areas of physics think there's no such thing as cause in the basic physics. It's just equations. Bertrand Russell once argued that, although he changed his mind later. And so I like to think it's very hard to think without cause. I think we really like to see things having effects and cascading downwards and looking at the branching architecture, if that's what it is, the cascade.
Right. What are the factors then that you found that facilitate this sense of wonder, this sense of drive to understand causal mechanism?
Well, to help it, if you're a parent or a teacher or just another adult, is to listen to the kids and ask them open-ended questions. Do not ask them how many X, Y. Ask them, wonder how this works, or what if we did this? Or what do you think this would be? Get them to think and generate longer responses. If you say, how many legs does it have? Versus, wonder why spiders have this many legs and other animals don't. Why are 5 digits so common across so many different vertebrates? These are the questions that work. But asking simply to report back facts or just say how cute that is, that doesn't get them engaged. So open-ended conversations and actually realizing you're sharing a partnership with them. All of us have enormous gaps of ignorance. And the more you wonder, the more you realize how little you know. And so when you're talking to a kid, you're not stuffing knowledge in their head. You're sharing inquiry with them. You're not the same status. You know more than they do about a lot of things, but you're both wondering together. And I think that's very important. When I interact with my granddaughter, I always like to disclose my ignorance and say, I don't know, let's figure this out. And I think that's very important for them to realize that everyone's in the same boat there. It's the same enterprise.
Right. Yeah. I mean, how much do you think the sort of repression of wonder is a result of our particular school system, right? I think of people like Ken Robinson, who've argued that really our schooling model is largely designed to create foot soldiers for the Industrial Revolution. We want sort of compliant workers.
Yeah, well, I don't know if I know that argument in sort of the sort of corporate tech school assembly line models. I don't know if that's all that's going on. I think there's some pretty liberal principals and teachers who wouldn't endorse that at all. But I think they still fall into the same kind of trap, which is they're in a school where they have a lot of kids. They have these mandates to get certain kind of performances out of the kids. And those performances, despite all our national recommendations from panels that you want to look at causal beliefs and mechanism, the tests are almost always fact-based tests. And I document this in the book. The assessments they have to train these kids for are not the ones that they care about. And so, of course, it's going to get stifled. And the poor teacher doesn't have the time in the class to engage in a back and forth conversation, to crawl inside a kid's head and jointly co-wonder. They're supposed to just dump their knowledge into the kid. So again, I don't think it's because they have this kind of a negative view of wonder, I think they just can't get it. They don't time opportunity. And they underestimate how much kids can do this. We've done a lot of studies showing that when you ask what they think kids can learn, they greatly underestimate it. We did one study where we showed kids a 7-minute video that is designed to teach adult technicians how to take apart and assemble and repair a diesel engine. And we asked teachers, could we show this to a kindergarten? Would they get anything out of it? And they said, of course not, it'd be stupid. They adored it, and they learned all sorts of abstract principles. And we had to do it certain ways, we had to make it work. But you can actually engage them in surprisingly abstract things, even before they can speak. Infants, I'll tell you one study we did that got me engaged in all of this. Imagine you see a display of objects. Let's say it's a bunch of blocks all scattered around the table. A screen comes up, and a ball rolls behind the screen. The screen comes down, and the blocks are all neatly stacked. Infants are very surprised at that. How can you create order of disorder with just a ball? But if the other thing happens, if it goes from an ordered array to a disordered array, they're totally okay with that. And through a whole bunch of studies, we've shown that they know before they can even speak that only intentional agents, goal-directed agents, can create order of disorder. And it's like entropy understanding. Now, how they get this, we're still trying to figure that out. It's now been replicated in several labs, so we know it's real. But that's very abstract, hard to even adults to articulate, but present well before they can speak. And so that kind of orientation and abilities, then we need to recognize more in them and nurture it.
And it seems to fly in the face of a lot of common wisdom around privileging concrete versus abstract learning among young children, right?
That's a myth. There's a lot of reasons people believe that kids go from concrete to abstract, but there's no good evidence for it. If anything, they're more abstract than they are concrete because they can't master all the details. You need to go to medical school to know all the diseases and all the germs and all the microbes. But some of the broad principles of healing and curing can be mastered much younger.
Yeah, it's been such a fascinating read. I mean, my own, I think of moments in my own schooling where I think I was really incentivized to memorize stuff. And, I think I did very well in science as a student, but it was largely just sort of regurgitating facts and formulas and so on. And I think, you win prizes for those things, and then it becomes a self-reinforcing incentive system. And so when I came across a physics and math teacher who actually was sort of a model for the kind of wonder-fueled science that I see among many scientists now that I'm studying, I just found him to be a crackpot. I thought, this guy's very strange. He seems to see mechanisms that drive everything. And we'd watch a movie and he would want to explain, why this particular thing moves in this way, and seem to have this love for seeing those patterns and processes. And
I mean, there's a tricky part to this, which is kind of like Richard Dawkins once talked about learning to play the violin and why it's kind of painful at first, but you get this great output at the end. It's good to memorize some things because they give you a platform to think with. If you don't memorize your timetables and your addition tables, you don't get to see the structure of math that lies beneath. You don't get to see how math is all about structure. It's not about doing processes. There's this incredibly rich architecture, and you can't see it if you're just if you have no sense of how the numbers lay out, and that means having to memorize some stuff. So I hate just memorization, but I don't think we want to have kids think that you need to get to some slogging to get to see the good stuff. And so the great teacher sort of makes that clear. Let's play this game. Let's get this in. Do it kind of not painfully. But once you get those facts in place, then you start to see how interestingly it is to have that. If you don't have some shared knowledge base, it's much harder to engage in productive discovery.
Right. So adequate description seems really important too, right? Not just sort of looking for explanation, but also laying out here's how things are structured and ordered. And
yeah, but not too much detail. Again, there's always a question of digestible chunks. You don't want to overwhelm them. You want to give them enough to give something to pivot on, something to use as a platform. Not too much, because you can always revisit it.
Right. So one of the things I want to talk about obstacles to wonder, again, among the scientists that we're studying. And one of the things that keeps coming up is stories of scientists who started out their PhD programs really fueled by wonder, really wanting to know how certain things worked, and then get caught up in this, as they certainly climb the career ladder, get caught up in the pursuit of, chasing after grants and the publisher pressure that they're facing. And we hear from people that scientists today have much less agency and autonomy in pursuing the kinds of projects that, say at the postdoc level than they used to 50 years ago. And we have scientists telling us that the sense of wonder that I had when I started has been beaten out of me by the pressures of the system.
It's a big issue. It's also, sadly, not equally distributed. If you're a faculty member in most medical schools, all your salary comes off grants. So that means you cannot even afford to feed yourself unless you're getting grants. Now, the grants that are available aren't always in your area of interest. They might be in some topic that's very applied and not really what you care about. But you got to keep turning those grants through, usually 2 or 3. I've heard of schools where the lab walls are literally on wheels, and as your grant income starts shrinking, the walls start shrinking in and going to other people. That's very bad. But even in places where you have a full-time salary, like I fortunately have had, the pressure is ramping up ever more to look at your productivity and developing a portfolio of publications. And the conservative approach is to work in one topic and really get deep into it. Don't take too many risks. And I think that's unfortunate because the excitement is taking a risk, trying something crazy and finding it works and being willing to fail. And that's very high stakes today. One of the things that's happened is, I think we talked earlier, everything is metricized now. You can look up. When I started out, I had no idea how I was doing. I just was pursuing ideas. But now you can look up and see how many people are citing you. There's these various scores of how productive you are. Everything is out there. It has a very different flavor. One of the scary things I've learned also, which I think de-incentivizes, is you're expected as a young investigator to market yourself. I heard a story recently which blew me away about a very hotshot molecular biologist who was being recruited by a number of schools. And some of the places asked him, so how are you managing your public portfolio? How are you doing your Twitter releases? How are you doing your Instagrams? Because we know that's important. I do the skills there to really rock up to the front. And I thought, that's the last thing you want. I mean, I don't like that because I feel like, how would I know that my stuff is really have an impact because of the science or because I'm a good PR specialist? And I think that is corrupting as well.
No, this is a really, serious issue. I wonder, in your own lab, have you found ways to help your team sustain their sense of wonder in the face of these pressures?
I wouldn't say I do it perfectly, but one of the things that's very important to me is that my students have ownership over a project. So I virtually never say, do study 3A in my grant. I have a research assistant who's paid to do that. And even those, I try to get some ownership feeling. So I often say, what do you care about? What do you like? And we brainstorm. And if I say, I don't resonate with any of this, then maybe I suggest they work with someone else on that project. But I'm ridiculously ADHD, so I'll pick up an interest in almost anything. In fact, I rarely publish more than 5 to 10 papers on any topic because I just get so bored. So I welcome new ideas all the time. And I tell them, I want you to become better at this and know more about this than I do soon. I want you to own it. And I think that's very motivating. And we try to do our lab meetings by always asking, why should we care about this? Why is this interesting? Why does it matter? Not because someone else published something, we have to replicate it. That's the last reason I want to do it. Sometimes you have to do it to get started, but that shouldn't be the primary motivation. You should say, this is just plain interesting. There's a hole here, and it needs to be filled because without it, we can't really tell the right story, the full story.
Well, it leads me to think about the relationship between wonder and something like humility, which seems really important for the current, challenges in science, like the replication crisis, and again, the pressure to overinflate your claims and so on in order to get funding.
I did some work with Templeton Foundation, which relates into humility, emotional humility. I think there's different brands. I don't think you want the emotional humility that means you're intimidated. You're not willing to be daring and bold. But at the same time as being daring and bold, you have to admit your ignorance, admit that others might know more than you. But it doesn't mean you shouldn't speak up. I've been in groups where the younger career people don't dare speak out for fear that they might get screamed or it's not appropriate. I want to hear what they think. So I think humility is so important in terms of recognizing that you might be wrong or be woefully ignorant or there are experts you need to speak to. But it's equally bad to be humble if it's paralyzing. If it means I'm just not good at this stuff, it's hopeless, I can't understand it, I should just be subservient and let the big guns tell me what to do. You should always be willing to try out your ideas and see what they think of them. I think there's a true wonder, in my sense, has a boldness to it, an adventurousness to it, while still realizing that you might be incredibly fallible and wrong.
You're listening to Beauty at Work. This episode of the podcast is sponsored by Templeton Religion Trust as part of a grant on the aesthetic dimensions of science. Templeton Religion Trust supports projects as well as storytelling related to projects that seek to enrich the conversation about religion. To learn more about them, visit templetonreligiontrust.org. This episode is also sponsored by the Institute for Advanced Catholic Studies, a global research center located at the University of Southern California. IACS works to create dialogue, spark ideas, and sustain academic research on Catholic thought, creative imagination, and lived experience. Learn more at iacs.usc.edu. If you're enjoying the show so far, please subscribe to our podcast and take a moment to leave us a review. Do you find that any qualities are required in order to persevere in the face of failures, in the face of being wrong? And because it could be incredibly discouraging for a lot of people to pursue a line of inquiry when success isn't forthcoming.
I don't study individual differences much, so I don't know that for sure, but I do think there's a pretty good literature suggesting if you focus on extrinsic factors as opposed to intrinsic factors, this goes back 50 years. So I want the fame of being a big professor or the big salary, forget that. But if I want some of these big kind of external factors to do this, you'd almost always be unhappy. But I said, I want to satisfy my urge to know why. I love unfolding this kind of structure that's going here. It's so cool to share in the thrill of discovery and to kind of high five, we just figured this out. And so to focus on those factors is important. And some people need a little guidance to see that's what really matters. Unfortunately, a few people want to go into research and academia because they love the idea of the prestige. That's the last reason you want to go.
Right. One of the other things that struck me about your work is how wonder can lead to an increased appreciation for the beauty of the world, which is one of the things that most of the scientists we talk to say. You write that science adds delight, not debasement, to our appreciation of nature. And it reminds me of a story that Feynman tells about an artist friend of his who complained that, oh, you scientists, you don't even know how to appreciate the beauty of a flower. You reduce it, right, to the kind of the way that Keats complained about the rainbow sort of thing. And Feynman said that's nonsense. Because I understand the deeper mechanisms, I can appreciate the inner workings of nature and of the flower.
I talk about this at some length because Mark Twain has a similar kind of quote, and Dawkins talks about it in the whole book. And Keats has this famous poem where he talks about how Newton destroyed the beauty of the rainbow. But I think it's a mischaracterization of Keats. Keats is actually a science freak.
Right. I didn't know about that until I read your yeah.
So I think you can make anything boring by being a kind of a drone about it. That's true of literary criticism. So I think anybody who wants to drill deep without kind of thinking about the broader picture can make things boring. And so scientifically analyzing something without stepping back and appreciating all that you see can be terrible. But that's just because it's done badly. I've never seen, what makes a rainbow less beautiful to know how it's composed of light frequencies? I think I totally blow my students away here when I explain them. There are no bands in the real rainbow. It's all imposed by our visual system. This is all a bias that we're seeing cut up in bands. And they balk at that. They say, how could this, they're so real. I say, no, they aren't. That doesn't make it less cool. It makes it even more impressive. And so I think it depends on how you present it. I think science, if presented like, you're wrong, here are all the details that show you're wrong, that's not the right way to think about it. This explains why you appreciate it and why it's interesting.
I mean, is it possible for learning to ever diminish our sense of wonder? Like whether you could lose your sense of the fascination with the mystery of something once you know how it works?
I guess. I've never had that experience, I confess. I'm trying to think of what would be such a case. I suppose if it's the deflationary, I suppose if you think, isn't it amazing? Oh, well, here's an interesting example, but I don't know if this diffuses it. So baseball players are remarkably good at catching fly balls, professional baseball players. Now, if you do the physics of it, it's incredibly hard because it's not just a parabolic trajectory. The actual trajectory of a fly ball starts like a parabola, but then air friction increases, almost flows straight down. So if they're doing the math in real time, it's a massive differential equation, which nobody thinks. What you find out they're really doing is they're keeping an angle of regard on the ball at the same angle. If it's at 32 degrees and they just keep it 30 degrees, they'll end up catching it. Now, you might say that demystifies it, makes it boring. I think it's cool.
Right.
But some people could say that, I thought there were these incredibly complex calculations, but that's all they're doing. But that, I think, is amazing. That's it. It all comes down to it. So part of this perspective, I think there are times you can find something be so deflationary. You say, this beautiful, wonderful thing was really just explained by a trick that someone used. And that might make it less interesting. I think that can add elegance to it.
Yeah. Huh. So this is for me, it's filling me with a more sense of wonder around those individual differences as to why some people are sort of disillusioned, I suppose, with this sort of knowledge, and others are actually spurred to learn more, to keep. And
I would look more to experiences they've had and less towards something about how they're made up. I think it's such a universal, deep part of us. There's obviously going to be differences in your first experiences, but I've never seen anybody who I couldn't, in a conversation, get intrigued. I teach a seminar I started doing Wonder a couple of years ago. And I tell these kids how many things they think they understand they don't, because I've done a lot of work on illusions of understanding, and how incredible cool it is to learn. And they have to make presentations each week about something they know nothing about. So one year, they did a lot of presentations on what happens during spring, about how the songbird's brain gets bigger, how certain flowers that come in early in the spring have ways of breaking through the frost, just a million different things. And they all agreed that as they watched that spring occur, it was a spring seminar, it had more richness and beauty and kind of enchantment than it ever had before because of what they knew. It's like going into a room in Technicolor and dynamic as opposed to a static black and white image. I mean, it really had that feeling to it. I keep on using the analogy of it's giving you better lenses in how to see the world. It's not telling you exactly what's there, but it's making everything richer and more powerful. Who would not want that?
Yeah, to be able to see things more clearly, to grasp
And deeper,
how things are. Yeah,
and see stuff that other people can't see.
Right. I mean, you mentioned illusions, and so I want to ask, can wonder ever be seductive, misleading? Could it draw us?
It can be weaponized if you constrain it. If you don't have what I call free range wondering, if you tell people, I want you to wonder on the best way to compact uranium into a bomb that can be the largest yield. That's not the kind of problem-solving wondering that I'm thinking about, and I think it loses its pleasure because again, it's got a strong external motivating force on it. And there are certainly cases where people have used claims of wonder to go the wrong way. But I honestly think if you're really honest to yourself and saying, did I really think about this in a fair way? Did I really kind of weigh the evidence and the sources? You're not going to do that. I mean, one of the things that I think I talk about towards the end of the book is sitting on this airplane flight with this guy who was denying climate change. And he destroyed me because he knew so much physics. But the one thing I forgot to ask, and I always regret this, I hope I get to see him again on the plane flight someday, is what would it take to prove you wrong? Because people who are agenda-driven are more like spouting a religion or a dogma if they don't have anything to say. That's the critical thing. As long as they can tell you, then you can have a real discussion. And I do that all the time with my undergraduates. I say, it's fine to tell me something you believe, but if you want to have a discussion, an argument, a seminar, you have to tell me how this is potentially disprovable. It's like Popper. And you'd be amazed how often that's something they haven't even thought about.
Yeah. Well, that's really crucial. That's a point that I think Adam Grant, the psychologist at Wharton, makes around part of what he says it is to think like a scientist is to be able to have the conditions under which what I'm saying, what kind of evidence would disprove this point or this theory or this hypothesis, right, is really.
Yeah, I think it's challenging sometimes. It's a little threatening, but it's also exciting. I actually don't mind at all being proven wrong. I've did a number of studies where I've had things turn out just the opposite of what I thought, and they actually blow me away. That's cool. It gives you more stuff to look at.
Yeah. Well, threatening is an interesting word because I mean that's again it seems to hold too. I mean we've had stories of scientists who tell us that they essentially were told you can't publish this because this is going to no one who runs this journal will publish it because it threatens their established paradigm and so forth. And so there are often risks that are at the level of career, but also then existential risks for people who, if something turns out to be true that threatens their sense of identity.
It's happened. I've seen it happen. It's happened to me. I had a brilliant graduate student. I won't go into details beyond saying that he discovered something that challenged the entire orthodoxy of an area. And he had to go through a series of rejections until we just overwhelmed the reviewers with evidence. And now it's become a major finding. And he had such persistence and diligence, and he was willing to be proven wrong, but he just kept marshaling more and more evidence. But a lot of kids would have quit. They would have said, I'm being beat up on these reviews. I can't stand this. So it does require you need an alliance. This is where mentors can be so important. They say, look, you're doing everything right. You may be wrong, but so far the evidence is supporting you. Keep at it.
One thing I want to ask about is how to improve trust in science. And one of the things that struck me, that I read in your book, was you talk about how strict objectivist views of the truth are more likely to encourage unquestioning dogma, which is often associated with strong feelings of tribalism. And there's ways in which it struck me that science is presented to the public that can be kind of dogmatic, kind of finger-wagging. And that, at least in the United States, seems to lead to a lot of rejection of science and scientists. We don't want this moralistic perspective, etc. And I wonder, are there ways to cultivate wonder and this sense of the beauty of understanding?
Well, we've done some work on arguing to win versus arguing to learn, and I think that's we have a Scientific American piece on this where we talk about how that leads to more objectivist attitudes. If you go into a discussion with another colleague and your goal is to beat them, the truth starts to matter less, and you tend to objectify certain things as being the key points to win on. If you go in with an open mind and you're saying, I really know what's going on here, let's argue, and you're willing to be proven wrong, in fact, you might be excited about proving wrong, that's a very different mindset, and dogma is much less likely to emerge. But, in the legal system, that's what you're supposed to do. But unfortunately, this gets often seen as what you're supposed to do in the science, and it should never be what you do in the science. You're never trying to win. The truth should win, and you should be trying to learn through an argument. That's why good lab meetings are always arguments. We have arguments all the time in lab meetings, but they're never in terms of trying to win. It's trying to figure out what's going on. You said this, but what about this? How can this handle this data? And it's back and forth.
Mm-hmm. Do you have then implications for how public communication of science might look different if we use that approach?
I think you should always make it clear that we're fallible and that we're trying to figure things out. I think we should try to invite people to be citizen scientists and help us, look at the data yourself, invite them to learn enough to be able to do that. I think we should tell them, ask about mechanism. Don't just look at facts. I think climate change is a fascinating example. It is extremely hard to understand the climate change models. And it takes some acts of faith to believe it's as devastating as it appears to be. Because when you look at the details, you can't do experiments with the Earth. You can only do sort of models. And then some of these computational models get very complicated. So I believe it because I've talked to enough people, but it is a bit of a leap of faith. That makes me uncomfortable. I wish I could have a more concrete feel about the greenhouse effect and how it's working and stuff. So I think you have to tell them to, when they present their work, admit they're fallible, and then hope that these silly algorithm-driven social network websites don't blow it up on you. I mean, one of the things that's happening, of course, is that these social media websites pick on the most extreme versions of your views, and people then polarize those. They're driven to work that way. That's what gets the most clicks and the most ads. And so I fear that there's these aggravating pressures out there that are hard to combat. But I think you should never try to oversell your findings. I mean, I always hate it when someone says something, they oversimplify too much. You have to find a level that can communicate with the audience, but I think should always illustrate there's complicated and there's more to learn. The whole COVID crisis is such an interesting example of not really managing information right. And I will be a lot more written about that, so I don't want to pronounce myself an authority at all. But it seems pretty clear to me, in attempts to be oversimplified and sort of make certain statements, people have lost trust. I don't know how they should have messaged it better. This is not an easy topic to go through.
Yeah, it seems there's a tension, right? And this is around that humility question, which is on how do you assert something with some confidence while also saying, look, this is fallible, right? This is what we know to the best of our knowledge, but could change tomorrow.
Yeah, I think you have to say just that and say, but my track record is like this, so I think I've been pretty successful at this. I'm not totally just throwing this up here, but yeah, I've been wrong on occasion. I think Fauci tried to do that pretty well. But he got battered if you ever put any qualifications. So they'll say, no, you have to be strong in the message. So, there's a lot of debate now about whether we're pushing vaccines. It's so hard that it's undermine the credibility of it. Believe me, I'm very pro-vaccine. But there are questions. You should always be questioning, how many boosters do you need? How much of the hybrid shot really works? What's really going on here? And people think, well, the public can't understand this. It's too complicated, so we'll have to simplify. But when you do that, you run the risk of them boomeranging.
Right. Yeah, that's been that's one of the big challenges, I suppose. And as we were asking scientists in terms of their own ideas as to what it would take to improve trust in science, and we wondered whether communicating the sense of wonder, even the beauty of science could help. And we were surprised. A lot of them said no, it won't help, because people are going to come to your findings, whatever set of facts you present, no matter how beautiful. They're going to come to them with their priors, and if they confirm what these people already are committed to, then they'll be happy to accept you. And if they threaten their priors, they won't accept.
I agree with that. I think that wonder isn't that's a solution unless it's kind of linked a bit to mechanism. It's hard for a charlatan to make up mechanism. People who make claims, if you say, well, that's really interesting, how does that work? And then they give you some glib story, say, so, but what about this? It's hard to invent mechanisms that work coherently all the way down. Most of us have holes in our mechanistic models as I talk, but the holes sound reasonable. They make sense. You don't have to know a lot. I mean, there are areas where I wouldn't be able to pull this off, but I'm always amazed that I could talk to someone in an area I know nothing about, and I can sort of tell whether they know what they're talking about by querying them. The other thing to do is look at their sourcing. We've done some work on this empirically. People often think, you need multiple sources to validate a claim. What they never see, and this is amazing, is that if all those sources got it from one prior common source, which is often the case, it's totally corrupted. And so we've done experimental research. People rarely take that step one further back. So teaching them to really look at the original information and see if it's really diversely collected or whether they all are starting the same. Unfortunately, network news is doing that more and more. They just clip stuff off the web. And so it's all coming back to the same single reporter standing in some corner hearing it as a rumor rather than really coming from different sources.
Yeah. Let's talk about how to cultivate wonder. I mean, you're in the closing chapter of your book. You've got a number of tips that are there things you would recommend. Let's start with, say, children. Are there things you would recommend that parents do?
Yeah, listen to them and do the open-ended questioning. Talk to them in ways that invite in conversation. Be partners in the conversation. Admit your own ignorance. It's the joy of co-discovery. You're not equivalent. You know more than them, but you still don't know a lot. And say, let's figure this out together. Teach them to respect sources and show your genuine pleasure in learning things. So that's one thing. Two, try to make the world more apparent to them. So if it's easy to take something apart, do so. Let them see what the innards are like. Don't try to hide them. Assume that complexity is never a hindrance. Something overwhelming complexity is fascinating in its own right. They may not know how every piece works, but they like to see it. They'd like to see, oh my God, look what the inside of that is like. I had no idea. Or sometimes the opposite. And so I think those are some obvious things to do at the family level. I've seen in some families, dinner becomes a really central area to discuss something fascinating and new. It's hard to do with everybody's chaotic life science, but to have a time of day where you sit back and say, did you see that thing about whatever, I mean, to give an example, the Webb telescope's recent discoveries that the universe has trillions of galaxies, each of which has trillions of stars. I mean, I know a very senior cosmologist who says, I'm still just blown away by the fact that this is so much vaster than I ever conceived. And yet we may be the only place where there's life. Now, that may be wrong, but so far, that'd be like 0.001% of all of reality has life. That's a staggering thing to learn. And so that's a great dinner conversation with your kids to have. I didn't say we always did it. All three of our sons went on the sciences in various forms. So I think we got them the wood tree, but maybe they're not always doing research, but they all were science majors. And so I think I'd like all the world to have that kind of orientation. Not that I think science is everything, but it's so much fun.
Yeah. What about at school for teachers who are, again, pressured by having to, produce, results at the testing level and so on? Are there things that they can do in spite of the pressures they feel?
It's hard. One of my sons actually taught Teach for America in New York City and was a high school science teacher, a middle school science teacher. And he had to run things on the weekends. He had to go to people's homes in the neighborhood and have them do things for health and stuff. There was not enough time in the classroom to do it all. So he said he's now a doctor, and he said medical school is nothing compared to having to Teach for America for 2 years in a tough school. And it was endless amounts of work. Now, it was incredibly rewarding, and he got these kids inspired. So you can do it. I'm not sure you can do it during the class hours if you have all these other mandates that you have to honor as well. Finland's done it, but through an extraordinary change in their whole culture. It took them 10 years. And that's a long section of my book that I go into. I can't really detail here. But it's not that you can change overnight.
Yeah. Finally, for scientists, those who are currently feeling that they're losing their sense of wonder, is there anything that you might advise them, or what can they do again in that current climate?
Ask them why they're doing this in the first place, why they go into the field. Remind them of hopefully that the original motivation was more wonder-driven, and point out that that's going to be the only rewarding thing in the long run. Not everybody can make it in the sciences and have a secure living, and so that maybe they'll have to be in some other discipline and still enjoy it. I mean, you have to be realistic at some points. If there are very few jobs, and if the things just haven't fallen your right way, or your equipment broke down, or whatever, maybe you're going to have to leave the field as a basic bench researcher. Hopefully not, if that's your passion. But don't do something you hate just because you think you need to crawl up the ladder. That's never a good recipe for our future.
Yeah. Great. Frank, any closing thoughts on, big takeaways that we haven't touched on from your book that you want our listeners and viewers to keep in mind?
I think in the end, I've written a number of books, but this was by far the most personal book because I'd learned so much more about my own self and how much I enjoyed asking questions. I'm getting older, and now I'm feeling this almost impatience to use every minute to learn more. I devour books about science across all the disciplines now because I thought, there's so much to learn, so little time. And it's interesting to see people who are truly polymaths have that feeling all the time, this hunger to know. And I think it's satisfying the same way as, and I use this analogy, you go into a new park, you want to know how the park is laid out. You want to see all the opportunities there and what their future is. So I think just realizing how rewarding this is And it doesn't cost anything. To be a consumer of this, not to be just a researcher, that can cost a lot. But to enjoy the fruits of science and to see the world more richly and deeply. I had cataracts removed about a year ago. And suddenly the world popped in color and crispness and it hadn't before. It's exactly the same thing. Learning some stuff through wondering suddenly makes the world pop. It comes alive in ways it didn't before. And that never stops. You know, I'm just reading Mukherjee's latest book on this, The Song of the Cell. And I've been trying to understand the immune system. And oh my God, that is the most complicated. I don't have a handle on it yet, but I'm dying to figure out a way to talk about and think about it that I can manage. And I'm so eager to attain that. And that's just rewarding as hell.
Yeah. Fantastic. Frank, it's been such a pleasure. Reading your book was such a delight for me, and it's even more delightful to have you here.
Well, thank you for reading it so carefully. I'm glad you liked it.
Yeah, you're welcome. Great. Hey everyone, thanks for listening to this episode of Beauty at Work. Please be sure to check out our show notes for more resources from our guest. And if you like this episode, please be sure to share it with your friends. And please leave us an honest review. We'd love to hear what you think, and it helps to get the word out about our show. Music for the show was provided by Venkat Subramaniam, and the podcast was edited by Dave Visaya from Podcast Engineers. And thanks again to our two sponsors, Templeton Religion Trust and the Institute for Advanced Catholic Studies at the University of Southern California. To learn more about our research project on beauty and science, visit wellbeinginscience.com. To learn more about our broader project on beauty at work, visit beautyatwork.net. Thanks again, and see you next time.